G'day ladies and gentlemen, and welcome to Pythagoras 3. With worded questions, it is very helpful to draw a good diagram that describes the situation in the question. Now, when I was doing my A-levels, we had lots of questions with lots of information going on. What I discovered was, if I drew a good picture, it'd help me get my thoughts in order as well, and I'd better tackle that question. In fact, with enough practice, I came out of all of them brilliantly. Now then, here's our question. A 2.5 metre ladder is placed with its base 1 metre away from the wall. How far does the ladder reach up the wall? Now then, if we consider each part of this first sentence first, that will give us a lot of clues as to what's going on. A 2.5 metre ladder is placed with its base 1 metre away from the wall. So, we have our wall, and we have our floor along the bottom. Now then, I know that each one of these comes to a right angle. They're at right angles, guys. So when I put the ladder in brown quite nicely, you don't have to make your diagrams colours, guys, but it can help. As soon as I put the ladder in, I've got a right angle triangle and I can use Pythagoras theorem. Now then, I've just got to put the numbers in the right places. A 2.5 metre ladder. We know the ladder's 2.5 metres, that's the hypotenuse, that's this side here. So I'm going to label it 2.5 metres. And it's placed with its base 1 metre away from the wall. There's the wall, there's the base, so it's this side here that I'm going to label 1 metre. Now then, I want to find out how far the ladder reaches up the wall. That's this side here. When I want to find it out, I'm going to call that x. I've got all the right things in place, so I can get straight into my formula. Now, remembering Pythagoras theorem, formula says a squared plus b squared equals c squared. And I always write that out at the start of the question, just so that I can see that I've got all my pieces in the right place. Now then, a, that's the smallest side, that's 1, so I'm going to write underneath a, 1, remember to square it, plus b squared. Now then, b is the second shortest side, which we've called x, plus x squared equals c squared, that's our hypotenuse, 2.5 squared. 2.5 squared. Now then, to sort this algebra out, I want to get this x by itself. Now to do that, I've got to do two things first. Now then, this 1 squared here is a plus 1 squared. I've got to grab that and bring it so it's with the other numbers away from the x. We call this taking away 1 squared from both sides, so we get a nice piece of practice with our algebra, with our rearranging equations. Now then, if we take away 1 squared from both sides, we're left with x squared on the left hand side equals. Now I can leave this sum as 2.5 squared, take away 1 squared, because we've got superb calculators nowadays, and they can handle us writing that. Now then, next line down, x squared. If I want to get that x by itself, I'm going to square root both sides. If I do it to one side, I have to do it to the other. And if we square root x squared, we're left with x equals what we've got before, 2.5 squared. Take away 1 squared, we've just square rooted it. There we go. Now then, I know my numbers, and I know that 2.5 squared is 6.25. Take away 1 squared, take away 1. That comes to the square root of 5.25. Now then, can be useful to leave our answer like that, but generally we have to round these things off. With my calculator, I'm going to do this to 3 significant figures. If we put in the square root of 5.25, we get 2.291. Now, because that's closer to 2.29 than 2.30, I'm going to leave this as 2.29 meters and say that's to 3 significant figures. Right, thank you ladies and gentlemen, hope you've enjoyed that. Have yourself a good day.